optimization class. The project that I chose was looking at a potential route, optimizing a route that you could take to travel to every major league ballpark in the United States and Canada. The MLB currently has 30 teams, and what I was trying to find out is what is a route that you could take to see all 30 teams. So for background on the solution that I chose, I use a traveling salesman style optimization, with the idea of having one salesman with 30 destinations. You're minimizing distance and calculating latitude and longitude to calculate those distances. For this, I had two different types of solutions that I ended up finding. One was a complete continuous route that encompassed all 30 ballparks. The other one was a regional route that looked at having separate subtours that were just independently connected routes that looked at a smaller, more manageable trips instead of one giant route. The model that I used was the code in the model was a traveling salesman problem solver base that was provided in just MATLAB examples. It's a mixed integer linear program that uses a binary integer. It assumes a flat Earth and just uses the hypotenuse to solve for distances. There are two quality constraints that are enforced on the solution. One is that there must be an equal amount of stops, or there must be equal number of trips per the stops, and at each stop must be attached to 2 trips. So at each stop there's an incoming and departing trip. So for the results here, I started off with solving for a continuous route. As you can see from the table here, these are all the teams for the MLB and that I was trying to connect and solve for. However, when you start off with just the unconstrained problem, most of the time you will get subtours. So for here in this first go, I had 7 subtours. So the goal from here was to try to eliminate them just to have one continuous route. The way that the solution does this is by implementing an iterative inequality constraint that will slowly take away the number of lines in each subtour so that eventually it eliminates that subtour entirely, and that process just keeps repeating itself until all the subtours are gone. As you can see here, a continuous route was found with an absolute gap of 0, so optimality was found. And so on the left here you see the map, and on the right you have the actual list of cities in the order on which would be the most optimal. A more useful solution was looking at potentially doing a regional approach. Rather than doing one giant route, you could break up the country into smaller subsets. One big problem that I saw initially with this is that we had some outlier cities, primarily Seattle, Tampa Bay, and Miami. With them just being kind of isolated away from all the other cities, I removed these to get a more satisfying regional subtour. So from here, you see once you actually solve it and you get these regional subtours, you can see that you get a west, central, and east subtour that actually fit fairly nicely. Once again, you have an absolute gap of 0, which shows optimality. For continuous work, what I would do is try and implement online map data, which would be used to better calculate distances and be better to get more accurate data. And finally would be implementing MLB scheduling. The big problem right now with this solution is that it would get you a route, but it might not necessarily be a route that would make sense based on the schedule. So developing a model that would incorporate that would be immensely helpful, and would be a great tool for any Major League ballpark fan to be able to see all these ballparks. That's it. Thank you very much.